Hello friend, this is Amit. Here I'm going to talk about the transfer function from a state model, how we can conclude the state transfer function of a state model. Let us see. So for that we have to take first we have to uh, see the standard equation of any state model, which is something like that: x a x plus bu. Okay, clear. And it's the input equation, and this one is the output side equation, which is like this. Okay, and we can name this equation as x1, first equation, and second equation. So the thing is that when we are talking about this equation, this is the standard equation which is given in any technical examination. Okay, from that we have to conclude the transfer function. So let us see how we can conclude the transfer function from this equation. So if we take the Laplace, actually this equation is in the time domain. So to get the transfer function of any equation, we have to take convert that particular equation in the frequency domain, so that we can get the equation in a very simplified manner and accurate. So let us first get the Laplace equation of that first equation. So for that, uh, the thing is that this is the input. So we can the first step is step one is to take the Laplace transform of this equation. Okay. So for that, we can write it as this. This one become x capital S, which show the frequency domain. Okay, and ax s plus b u, and in the frequency domain term. Okay, so when we simplify this equation become as this terms, and this terms. This one comes here. Okay, so this equation become okay, and this one remains here itself, and it's become here. So this equation become x. Actually, in the simplified manner, now you can also write it uh, uh, you have a question in your mind that why we are taking I here. So I is the identity matrix. That's basically the same function as because the S because here we are dealing with matrices. Okay, so the thing is that we need a matrix to solve that particular equation. For that we take this identity matrix. So there's nothing else, and this one becomes something like that. Let's come here, and this one become okay. Now if we uh, take the inverse of this equation, so this equation becomes something like that, which we can easily solve. Okay, this one is the function of x in frequency domain. Now we have to take another step to get the solution for this equation output side. So for that we have to take a step 2. Now solve it. Again we have to take the Laplace transform of this output equation. So for that, this equation will become C capital S, as we are converting this in time frequency domain. So this becomes something like that. Okay. Now here we are having x, okay, and here s, here u. This is the capital, this is a input side equation. Now the thing that we have here is we are having x in the term of, this is the x term and this is the x term. So what we can do, we can directly put this equation, y equation, into this equation. So the equation, we are putting x value in this equation directly, so that this equation become y is, okay, and c become this side, and this equation become s I minus a inverse b u s whole bracket plus d u x. Okay, clear. This equation becomes something like that. From this equation we can get the transfer function of this equation. So this equation is something like that, and now we have to conclude this equation. So this equation, when we do further simplification, it's become, let's come here, s I minus a inverse du, okay, and s d u s. Okay, now both the term having input side equation, this one is the input side equation which we are going to take in the transfer function case. Okay, because the term that's enter from the input side is u, not the x. Okay, when we are taking in when we are talking about any block diagram, the signal that is enter from input side is considered as a u with a sign of u. This is a standard equation. So now proceed to convert, to further simplify this equation. This equation become c s I minus a inverse b plus d, and this us comes out. Now down this equation as this gives the transfer function of state model. This is the standard equation of any standard model in term of transfer function. Okay, clear. This is the d side. Now you can conclude any state model, okay, into its transfer function. This is the standard transfer function equation which we conclude for any state model. Thank you for being with me.